Hey everyone, today we're going to be talking about polygons and how to get the area of polygons and what that actually means. Some of us started these notes in class, so if you already have them, you don't need to redo them, but for those that weren't here today, can get caught up this way. So we talked about a polygon is a two-dimensional shape that is made up of three straight sides and is closed. We talked about a square, how it has 90-degree angles and all the sides are equal. To get the formula for the area is area equals base times height. We also got to the rectangle, and those are the notes down there, still with these 90-degree angles, and the opposite sides are the same. And that is how, and they have matching ticks. So this one only has one, top and bottom. On the other side is two ticks, so the opposite sides are equal. Area is still base times height. A new shape is a parallelogram that looks like this. And the thing about a parallelogram is all of the sides, opposite sides, are parallel. So on my sides here, these two lines are parallel, and the top and bottom are parallel. And I show that by having just one arrow or two. And remember, parallel lines are lines that will never intersect. So this set of parallel lines, if I were to extend this forever on the top and bottom, they would never intersect. Same thing with the sides. If I were to extend those forever, they would never intersect. To get the area is the same formula as what we've seen, base times height. Now here's where the base times height really comes into play. Base times height, the base and the height, that relationship is they meet at a 90-degree angle. It has to be a 90-degree angle. And for our square and our rectangle, they do meet at a 90-degree angle. Height and base, they meet at 90 degrees there and here. This is not the case here for this side and that base. That is not a 90-degree. So this is not the technical height of a parallelogram. The height meets the base at a 90-degree angle, and it's going to be this dotted line here. I'm actually going to draw that right angle symbol showing where the height and the base meet. So it's really important, especially for parallelograms, to be looking for the true height, not this length here, really the height that meets the base at a 90-degree angle. So that's a parallelogram. Feel free to pause this anytime and get caught up. I'm going to go through this kind of quickly because I want to keep this video short, but all the information is here for you. Our next shape is a trapezoid. And it's not coming super clear. Let me see if I can help that out. Be right back. No, not much better. Here's a trapezoid. Sorry about that. The thing about a trapezoid is it just has one set of parallel sides. Parallelogram had two. A trapezoid only has one. Those parallel sides are known as base and the base 1 and base 2. Notice that these sides are not parallel lines because if I were to extend them out, they would eventually cross. Whereas the top and bottom lines, they would never cross. And I know it's hard to see here, sorry about that, but this dotted line shows the height. Again, the height meets the base, either base, at that 90-degree angle. The area of this one is a little complicated, but I take the height, I multiply that by B1 and B2, and those are the top and bottom, the two parallel sides. So I add these two together, and I multiply by the height, and then I divide all of that by 2. We're going to do a couple example problems and show what that actually looks like figuring out the height. And our last shape, something that we are familiar with, is a triangle. A triangle just has three sides, not so super special. But to find the area of a triangle, I take the base, I multiply it by the height, just like what we've been doing. But now I cut that in half, or I divide it by 2. And again, I keep saying it, but it's really important. The base and the height meet at a 90-degree angle here. So if I were looking at this light blue one, this length here is not the height. The height is what meets the base at 90 degrees. And this dark blue one, it does that already with my 90-degree. Okay, so feel free to go back and get those notes down, but that is all the shapes we're going to be talking about for this unit. 1, 2, 3, 4, 5. Start getting familiar with those and start understanding what their formula looks like. Let's start looking at some area problems now. So I'm trying to find the area of all these shapes, but let's just do it one by one. Let's start with this. What shape is this? Well, this is a square, and we know that the area, the formula to the area is A equals base times height. Now, area, remember, is the space inside of this two-dimensional shape. I think about it like how much paint it requires to cover the inside of that. And the way it's measured is these little squares. And what we're trying to do is figure out how many of these little squares can fit inside of our shape here. So that's going to be the units that we're going to come up with at the end of this problem. So let's fill this in. So A is what we're looking for, is base. Well, in this case, the base is just 4. And in this case, the height, the H is height, that's also going to be 4. And what's special about squares is the base and the height are always going to be the same. So all we need to do now is 4 times 4, A equals 16. Now let's think about the units. The units here was inches, but we talked about how many squares are going to be inside it. So the units for any area problem is units squared. In this case, the units are going to be inches squared. That's one way you could say it. You could also write it as 16 square inches. So this is basically saying I can fit 16 of these little squares inside this space here, and that is my area. Moving on, I've got a parallelogram here. Remember, a parallelogram has 2 sets of parallel sides, and I find that area in the same way that I do a square or a rectangle. Base times height. I just got to make sure that I'm finding the correct base and the height. B, base is 4. Height is 3. So all I need to do is multiply 4 times 3 equals 12. But in this case, my units are feet. So my area is going to be feet squared, or 12 square feet. 12 of these little squares I can fit inside of my shape there. I know I'm moving fast, so feel free to watch this again or pause and get caught up. Okay, this is a trapezoid. Remember, trapezoid has 1 set of parallel lines, only 1. And the area is a little more complicated, is height times B1 plus B2 all over 2. So let's fill this in. You can either go down or to the side. Might do a little both here to figure this out. So again, I'm just identifying what the height is. What's the B1? What's B2 from our shape over here? Well, the height, that's going to be 5, parentheses. B1 plus B2, those are my parallel lines, the top and the bottom. So it's going to be 4 plus 6. This is addition, so order doesn't really matter. If we wanted to count this as B1 or that as B2, we'd end up with the same thing. And then that's all over 2. Let's clean this up. This is like order of operations. We need to do the parentheses first. 5. 4 plus 6 is 10, all over 2. We need to do some multiplying up top before we can divide anything by 2. 5 times 10 is 50, all over 2. And my last step is just how many times does 2 go into 50, or what's 50 divided by 2? Cut in half, that's 25. And that is my answer. But my units are in centimeters. And remember, whenever we're talking about area, we're talking about squared. So we've got 25 centimeters squared. And my last one, this is a triangle. The area for a triangle is base times height over 2. Let's fill that in. Don't want to get confused. My base is 10. My height is 8. All over 2. 10 times 8 is 80 over 2. Half of 80, or 80 divided by 2, is 40. And my units here are yards. So I'm going to say yards squared, or 40 square yards. And that is area of polygons. Thanks for watching.